Hello. So in this video we're going to be finding the area of a regular polygon. Well, first of all, we need to define that. So what's a polygon? A polygon is some two-dimensional closed shape with some number of sides, like what you see before you. For instance, this is not a polygon. This is not closed, right? This is not a closed figure, it's open. Not all of the sides connect to each other. The final side does not connect to the first side. It's not a cycle like this. But what's a regular polygon? So I'm going to say this is my regular polygon here. And let's just pretend this has n number of sides, just some number of sides. This one has 6, but I'm going to pretend that this has some variable number of sides. I'm just going to use 6 because it's kind of helpful for the presentation. So our polygon here is regular for two reasons. First of all of the sides of some side length s are congruent. They all have the same length. Alright, and all of the interior angles, well, all of the angles in general, are also congruent. I'm going to call that theta, which is a Greek letter, but we are not going to focus on that too much yet. This is a regular polygon. This exactly is a regular hexagon, obviously, but let's pretend it's some regular polygon. So how could we approach finding the area of this figure? Just some polygon. Well, what's usually helpful whenever we're trying to approach a problem like this is to separate it into simpler, more kind of coherent parts. So let's try to find a shape that we do know how to find the area of. And here's a neat thing about regular polygons. There's a center of a regular polygon that is an equal distance from all of the vertexes here. The vertexes are the little points between sides. They're transition points, essentially. So if we draw these lines here, these will all be of equal length. And pay attention. What am I drawing here? I'm going to cut my angle in half. My drawing in half. We've just made 6 triangles for our 6-sided figures. Well, wait, this is not a 6-sided figure. This is an n-sided figure. So we have n triangles in there. N number of triangles. So we have some number of triangles, n. That's just the variable, we're calling it n. So here's something we know how to find the area of. We know how to find the area of a triangle. And just so you can be sure, these are all congruent triangles because, like I said, these are all congruent lengths. So all these triangles are congruent. They all have the same lengths for sides. All right. So if we can just find one of these triangles, we know that for n sides, there are n triangles. Look, because we have 1, 2, 3, 4, 5, 6 sides here in our diagram, and 1, 2, 3, 4, 5, 6 triangles. One triangle for each side, right? So if we can find the area of one of these triangles, we should be able to just multiply it by how many sides there are in our figure, n, to find out the area of that total regular polygon. Alright, so how do we find the area of a triangle? If you probably remember that the area of a triangle, AT, is equal to 1/2 times the base of the triangle times the height. So if we have some triangle here, that's not a great triangle, but let's just say this is a triangle. Here's our base, and here's our height. They're perpendicular to each other. We think x and y axis. And we're multiplying by these two by each other and dividing by 2. So what's our height on this triangle? Well, first of all, the base is quite obvious. The base is just the side length here. Let's just focus on this triangle, because this one seems simplest. Just because it looks like it's resting flat here, if we're thinking in x and y axis terms. So this is our base. And what did we say that was equal to? S. The side length is of length s. So our base is going to be length s, and our height is this thing here. This is our height. And there's a special term for this thing. It's at a right angle from this line, and it's bisecting it. So it's a perpendicular bisector. This is called the apothem. So the apothem it will just act as our height. We can just plug it in. I'm going to call it A. So let's plug these into our formula. We have 1/2 for the area of one triangle equals 1/2 A, that's the height, times S, which is the base. So now all we need to do is find how many triangles there are. So in here we have 6, but let's just say we're dealing with a polygon with n number of sides. We don't know how many, but we know it's some number. And there are as many triangles as there are sides, so we can just, for the area of the total polygon, write, the number of sides divided by 2 times the apothem times the side length. Now here's one more neat thing to do. The side length times the number of sides, what is that? How do you find the perimeter of a polygon? You add up all the sides, right? But if all of these sides are equal to S, and you're multiplying S by that many sides, that's the same as just adding S all those times, right? So n times S is the perimeter. So this is equal to the perimeter of the figure divided by 2 times the apothem. And we have found the area of our regular polygon. Now, what you may be wondering is, well, what is this apothem all about? How do I find an apothem? If you're in earlier geometry class, they'll probably just give you the apothem, because finding the value of it based on more usual values like the side length and the angles requires some trigonometry that you might not have known yet, or at least that's how I'm going to teach it. So if you're not yet familiar with trigonometry, just be happy with this definition and come back when you're ready. But if not, keep watching, because I'm going to fill you in on how to find the apothem based on side lengths and angles.